I can tell I am about done making videos for the day. I hope y'all are well. I hope the assignments are making sense, or the conceptual's making sense. But ultimately, this is the fun part of energy. You can make these predictions of speeds using this concept of conservation of energy. We do have to make a couple assumptions, okay? First, if I'm going to get the roller coaster car to the top of the hill, we're clicked in, we're going click, 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 click. That's a force over a distance, and they're adding energy to the system. But if you recall, on the top of those roller coasters, it's like they have you just sitting there, and then gravity starts taking you down. And if I want to find out how fast I'm going at this hill, I have to know how high I am there. And so we evaluate, right, how much energy do I have in the system by its peak height, and then I can figure out all that energy that's right here, right, has to be part of this, okay? It has to be, all that energy has to be represented. I can put mass of a cart. I'm just going to say the mass of the cart is 500 kilograms. I really don't know how heavy these carts are, so I'm just going to let it go there. So the way we evaluate it, if there's no work being done, we're letting gravity start the motion, my energy at state 1 is going to be the same as that energy at state 2. But all of this energy, all of that energy is what kind of energy, right? If we're sitting still and we're waiting to get pulled over that edge, I've got potential energy 1 equals mgh, but my kinetic energy when it starts is 0. So energy 1, this is my potential energy right there. All that potential energy is now going to be split between these two, which I've got potential energy 2, mgh2, and I've got kinetic energy 2, and that's 1/2 mv squared, and that's the velocity at state 2. So how do I know it's still moving? How do I know it's still moving? Because all of this energy is about potential, and now the potential is not, the energy is less than that for potential, so it has to have kinetic energy involved. So that's potential energy 2 plus kinetic energy 2. Now I'm going to go back to black just in case that is not showing up well. So let me put my information down. mgh1 equals mgh2 plus 1/2 mv squared. Okay. Now I'm putting the mass in right now just to evaluate it. How much energy do I have here? That's 500 kilograms times 10 times my height of 20, and I'm just comparing it to 0, ground 0. So 5,000, right? 500 times 10 times 20 gives me 100,000 joules of energy. Now the thing is I can use that 500 in each one of these, and maybe I'll do that. Let's do that. But mathematically, you know what's really nice is that mass is in every single term, and because it's in every term, we can factor it out and cancel on both sides. But let's do the math with it. Okay, so I've got 500 times 10 times 20 equals 500 times 10 times, related to 0, 5, plus 1/2 500 v squared, and that's that velocity at part 2. So this is 100,000 joules, right? Now, if you notice this, you've got 5,000 times 20 and 5,000 times 5. I'm ultimately going to have 5,000 times 15. But let's do 5,000 times 5. That's 25,000. And that's 250 v2 squared. So when I take this minus that, right, I should get 75,000 equals 250 v2 squared. Right. So I'll divide both sides by 250. that is 300. And then that's v2 squared. I take the square root. That is 17 what? 0.3 meters per second. Now I'm going to pause, and then I'm going to go find out what 17.3 meters per second is in miles per hour. All right, let me get that back up. And did conversion. That is about 30, oh darn it, 39 miles per hour. Okay? So again, if I want to find out the speed of how fast I'm going on a roller coaster, right, I can use the energy method where I find out what kind of energy I have. There's no motion here. Even if I knew how fast I was going, I could plug it in, right? But I have to know what it is. And then I could say mgh, I know that height, and I can find that speed. So your assignment is going to have 2 items. One, you're going to find the speed at the base of the mamba, so I'll give you some data on that. 2, you're going to find the speed when you're released from the ripcord at the bottom. And then 3, I think I might make extra credit, is the Patriot. I want you to find how fast you're going, not at the top, not at the bottom, but in the loop, at the top of the loop. Okay? So that will be your assignment. I'll have a little worksheet. You guys will do your work, and with a little extra credit possibility, but also kind of fun that if you were to take, like they call it 5Fox app, although can you have your phone on the roller coaster? If you take your phone on the roller coaster, you can find how fast you're going at the end and see if it matches. All right, I hope that helps see the practical aspect of conservation of energy. I think it's pretty cool, and it helps solve, I think, a lot of practical problems or interesting facts about things. Okay, bye.